Good morning, guys. How is your day? And welcome to my YouTube channel. In the last two videos, I discussed about the flow for SIPI engineer and stack up, how to design the better stack. Today, I am going to discuss the classification of signals in PCB. So there are many kinds of signals in the PCB. So what we do, like there are many types of signals like such as high speed signal, and high speed signals is also different types, like some maybe 400G signals, 50G, 100G or 25G signals, 40G or 10G signals. Nowadays even the PCB have 800G signals also. So another are there PCIe, DDR, USB. I will discuss about this PCIe, DDR and USB in details in further slides. Another one is the clock signals. Clock signals are also very important signals. Power signals and the ground signals. So these are the basic types. These are the basic types of signals available in the PCB. There may be many more, like this clock signals may be divided into several other signals. Power signal will be divided into like 12 volt, 3.3 volt, 1.2 volt. All will be divided. There are many kinds of power, right? Even 12 volt, high power. So all these signals you need to divide. Now the questions comes, right, why we need to divide this signal? Yeah, we have to divide these signals because we have need to give some gap, some gap, some spacing between these signals to avoid any crosstalk, to avoid any signal integrity problem. So for that we need to create a spacing table, which I am calling now here is the spacing table, but different company may give this one a different name. But basically this is the spacing table, and we need to enter this information in the layout. So in the layout section there is one term called the constant manager entry. So for constant manager entry we have to give this all this value to layout engineer, and they will fill this value, and SI engineer is responsible to check either all this value are correct or not. So suppose it starts with 100G signal. So 100G signal to, again, between 200G signal, what should be the spacing? Either region. This is the region, means open region. In on any other, on any PCB, at any PCB place. So again the line to line, like we'll have transmission line, right, or trace. So what should be the spacing? Line to via, what should be the spacing? Or via to via, how much should be the spacing? Again 100G signal to any other signal in the open region, there may be, again, yeah, 100G to 100G, 100G to any other signal. So this will consider the high speed signals, you need to have some bigger spacing. Yeah. So again I have given the region here open, so there may be another region like inside IC or below the chip. You can say below the chip it's not possible to have this much spacing, so below the chip we give like sometimes 5 mm, 40 mil. All this value are in the mil, 40 mil, 25 mil, 20 mil, 40. All the, I forget to mention here, but this value are on the mils, MILS. So PCI 3.0, again PCI in the open region around this value, having this value. Again PCI to any other signal having same, this will have the same value, 30, 20, 15. So try to this, we get this value either from the experience or from our colleague, those who are already working, or even if someone wants to do simulation, so they can do the simulation, and they should know what is the crosstalk limit, what is the insertion loss limit, what is the return loss limit. I will discuss all this in the scatter one. I will make videos for the scattering parameters. I will discuss what is insertion loss, what is return loss, or what is crosstalk. Mm. So now you need to understand just these things. You need to have value, and you should enter this value in the constant manager. Why we are doing this? We are doing this to make the better PCB product, so that our PCB will be robust and have longer lifetime. Because even if we give here, suppose we are giving here 40, even if we give line to line here 30, this may work, but the lifetime of the PCB may degrade. The PCB used for like any switch product in the data centers. Now clock signals is also very important. Clock to clock or clock to any other signals, how much should be the spacing, line to line or line to via or via to via. Now power signals also having very many kinds. So you can discuss with your colleague how to divide these signals. So you have to again decide this to how much should be the spacing between this power signal and ground signal to any other signals. So we know that okay, ground signals maybe not going to get create any problem, so we give always spacing is 555 for all the line to line or line to via or via to via. So in the next slide, in the next video, I will discuss about this PCIe, but for now you need to understand the classification. So I have discussed about the classification, spacing, the preparation, classification will come here, and constant manager. So with these two slides help you to understand um, the flow related to classification, spacing table preparation, and constant manager entry. So we have covered till here constant manager entry. In the further slides I will slowly discuss about that PCI, DDR and USB, and in further again I will discuss about the scattering parameters. That's all guys for today. Thank you guys, thank you for the time. Have a nice day. If you like this video, please press the subscribe and like button. Goodbye.